So in this video today, we're going to try to solve the bearings for these missing sides given our interior angles. And there's a drawing here of the traverse, which could be a property ownership or something along those lines. And we're given an initial bearing for side A to B, which is south 8 degrees, 36 minutes, 14 seconds west. The drawing looks fairly accurate in terms of that direction. And then we're also given the interior angles at each point there. So the first thing I do is draw a compass rose through the center of each point. And I can then kind of visualize that. So I've gone ahead and done that on this similar page. We're not really needing to compute anything at A at this point. So we're going to start here at point B. And I've gone ahead and drawn just zoomed in views of each point. You can, some of you might be able to solve it just using what we have here. Others might need to see an actual larger drawing, and that's generally what I will do, is just have a larger drawing. So we're going to try to determine what is the direction of this line here. That's what we're looking for, is the bearings for the missing side. So we're looking for B to C. So first thing I do is always draw what I know. Well, I know that the bearing from A to B is 8 degrees, 36 minutes, 14 seconds. And so that would be this little angle here. That's our 8 degrees, 36 minutes, 14 seconds. And then I also know our entire interior angle at B, which is this number here, 215 degrees. So that goes from here all the way around to here. And that is 215 degrees, 51 minutes, 58 seconds. So we know that our bearing from B to C is going to be in the southeast quadrant. So it's going to have a direction of southeast. We just need to figure out what is going to be the remaining component of it here. So hopefully you visualize that, and what we need here is this angle is what we're going to determine. So it's just a bunch of subtraction. Since we know the entire angle, right, we know that's 215 degrees. 51 minutes, 58 seconds. We know this portion of the circle, which is 180, so we're going to subtract 180 degrees from that. And we know this little sliver of it as well, so we're going to subtract the 8 degrees, 36 minutes, 14 seconds. And we're going to sum that up, and we should end up with 27 degrees, 15 minutes, 44 seconds. And so we can plug that in to our direction here. So we'd be going south, 27 degrees, 15 minutes, 44 seconds. East. And that would be from B to C. And now we'll continue that down. So knowing that that was what our calculated angle is, we can continue and find that that is actually this angle here, 27 degrees, 15 minutes, 44 seconds. And that our interior angle at point C, so our interior angle here, is 51 degrees, 40 minutes, 28 seconds. And it appears to be drawn correctly in that the sum of these two angles is going to be less than 90, which would be correct. So 90 degrees is over here. So if we're looking for the bearing from C to D, which is our next one, we're going to want to know this angle. So essentially the sum of those two. So it's just an addition problem. So for C to D, we're going to have our 27 degrees, 15 minutes, 44 seconds. And we're going to add to it 51 degrees, 40 minutes, 28 seconds. And we're going to end up with 78 degrees, 56 minutes, 12 seconds. And we are in the northwest quadrant. So that would be our bearing from C to D. We're going to carry that angle over for D to E. So our back bearing would be this angle, which we just calculated, 78 degrees, 56 minutes, 12 seconds. We know our interior angle at D, which is this angle, as 111 degrees, 6 minutes, 33 seconds. So in this problem, we're looking for the direction from D to E, which would be this angle. And to do that, we're going to do just some subtraction. I generally start with the large number, so 111 degrees, 6 minutes, 33 seconds. We're going to subtract off of that the 90 degrees here. And then we're not quite done, because that will give us essentially everything, but we need to know this little component here. So to calculate this component, I'm going to take 90 degrees and subtract the 78 degrees, 56 minutes, 12 seconds. And I will come up with the remainder, which is just this little sliver here. And that should be about 11 degrees. So it's 11 degrees, 3 minutes, 48 seconds. So I'm going to subtract that from up here, from that value, 11 degrees, 3 minutes, 48 seconds. And that will give us our total sum there, which would be our remainder in the angle that we're actually looking for. And that turns out to be 10 degrees, 2 minutes, 45 seconds. And we are in the northwest quadrant. And for our last problem, we're determining E to A. And so we know the opposite interior angle. So that's what we just calculated, was 10 degrees, 2 minutes, 45 seconds. And we know the entire interior angle at E. That was 124 degrees, 36 minutes, 38 seconds. And we are looking for this angle, the bearing from E to A. So it's just going to be a subtraction problem again from 180. So 180 degrees, because we know half the circle. Subtract the 124. I'll put it down here on the bottom. The 124, 36, 38. And we're going to subtract off the 10 degrees, 2 minutes, 45 seconds. And we end up with 45 degrees, 20 minutes, 37 seconds. And we are in the northeast quadrant. So all these are being reported as forward bearings. So hopefully that helps you solve the mathematical problems for determining bearings from interior angles.